Hey guys, so this is a basic examples video of negative exponents. So if you just feel like you need a little bit more to kind of get it down, I tried to make these not crazy hard, but I have a bunch of examples. Highly recommend you pause and try the examples. Also, I have them all written down in my free guided notes at divideandconquermath.com. So here's page 1 of the examples. You can pause the video and read them over if you want. And then here's page 2. So I have 8 examples. So hopefully you feel like you've kind of got the basics down. I have another video of just tricky problems after this. Okay, so let's get started here with A. So this one's just a reminder of how to, evaluate these. So in general, when you have just numbers and you have this, so the thing I want to remind you of is you flip the entire fraction to get rid of the negative exponent. So notice I flipped this, now this is positive, and now I can really just square the top and the bottom like this. So this is going to be 25 over 16. Okay, now for B, so the thing with negative exponents in general is you can't have them in your final answer. So for this one, there's really nothing to simplify except you have a negative exponent here and here. So those need to move. Now remember, you don't have a negative exponent on the 3, so the 3 stays put. So if this doesn't make sense to you, this is something I talked about actually in depth in my lesson video on negative exponents. So if you feel like you're a little, shaky on them, I highly recommend you watch my lesson video. Okay, so the 3 and the y to the 4th stay on the top. The x to the 6th and the z squared go to the bottom. And you could have the letters flip-flopped if you want, but this is the structure. And actually, that's all you have to do for this one. Okay, now for this one, kind of similar to the last one, except in this case, so I have a negative exponent here. So I have here and here. Okay, so in this case, this is all I have to do is move these two. So the 4 stays on the top, the y to the 7th stays on the top, the z to the 5th will come up to the top, and then the x to the 4th will move to the bottom. Okay, so for this one, so now we're getting a little bit more complicated here. So 6x cubed y to the negative 5th over x to the 7th y squared. So there's only one negative here. So I highly recommend kind of taking this in steps. I usually like to get rid of the negative exponents first. So I have this situation here. Okay, now the second thing I like to do is I like to do the product rule before I do the quotient rule. So these here, the exponents here can be added. So this is going to be 6x cubed over x to the 7th, y to the 7th. And now for the last one. So this is a little bit tricky here. So I've got these x's. Now, I want to explain something about the quotient rule. The quotient rule, just to remind you, looks like this. So you've got, you always take, you take the top exponent minus the bottom exponent. So this is 100% true, but I want to show you a shortcut. So let me get rid of this for a moment, and let's just think about this for a moment. So where are there more x's, on top or on bottom? In this case, there are more x's on bottom. So basically, like a shortcut for this is wherever there are more of that letter, that's where your answer is going to go, and you're going to do the subtraction in that direction. So let me show you what I mean. So I've got the 6 is going to stay on the top. So there are more x's in the bottom. So this was x to the 7th, and I'm going to subtract the 3 away from it. So I'm going to subtract this exponent, and then I've still got the y to the 7th. So this is a trick you can always count on. So if there were more x's on top, then the final answer and the subtraction would go on top. So this is a little shortcut that I think is super, super handy. And I just want to kind of round out this explanation, I guess. So let's see, let me use a green color. So I have x to the 3rd over x to the 7th. So let's just talk about this just slightly more in case this doesn't totally make sense to you. So I could totally use the quotient rule here, right? So I can do the top exponent minus the bottom exponent. And this would give me x to the negative 4th. And then what would this require me to do? This would require me to send the x to the bottom because I'm not allowed to have negative exponents. So basically what this shortcut I'm showing you does is it just kind of allows you to jump over these two steps and just say, I can see there's more x's in the bottom, so I'm just going to say that the answer goes there. Okay, so E. So once again, you might want to pause and try this one. So I've got 14x to the negative third, y to the fifth, z to the third, over 21x to the negative second, y to the negative third, c to the ninth. Okay, so lots of stuff to move in this case. So this has got to move, this has got to move, this has got to move. So let's do some moving and shaking here. So I haven't even dealt with the numbers at the moment, but I'm gonna see. I like putting everything in alphabetical order, so I brought the x to the second up. I've got y to the fifth, and then I'm putting the y to the third next to it, and then I've got that z to the third. And then all of this is over 21. Let's see, the x to the third will come down, the y's are gone now, and then I've got the z to the ninth. Now I like to put kind of the letters together just so I can help visualize them. Now, as I said in other videos and in this video, I like using the product rule first, so I'm going to add these together. So I've got 14 x squared, this will be y to the eighth, z to the third, and then this is 21 x cubed and z to the ninth. Okay, so now this is where that little exponent trick that I just showed you in the last example, it will come in handy here as well. So notice, where are there more x's, on top or on bottom? There are more on bottom. And then what about for the z's, on top or on bottom? So once again on the bottom. So what that tells me then is I can do the subtraction of the smaller exponent from the bigger exponent, but it's just going to be on the bottom. So this is going to be 14y to the eighth over 21 x to the 3 minus 2 and z to the 9 minus 3. Okay, now one other thing, actually let me finish that and then we'll simplify the numbers. So this is going to be y to the eighth, 21x, and then, oops, z to the 6th. And now I can divide the 14 and the 21 both by 7, so the final answer is 2y to the 8th over 3xz to the 6th. Now there's a couple of different orders I guess you could have done this in. Maybe you decided to simplify the numbers first, and that's fine, but this would be the final answer that you should have gotten to. Okay, so for this one, so I actually talked about this one also in my lesson video. Okay, so I really need to take this 2 and just distribute it across the whole problem. So what does that look like? So this is like 3 squared, x to the negative fourth times 2, y to the negative second times 2, and then z to the fourth times 2. So I like writing out this squared so that I don't forget, and then some people have problems, like, and I totally get where this comes from. They're like multiplying, and so a lot of people will fall into this trap of doing 3 times 2. So you really, so I think sometimes by writing this out and then telling yourself this means 3 times 3, that can be a helpful little hack if you find that you have problems with this. So if I continue to evaluate all of this, so I've got all of this. Now I can't have negative exponents, right? So these 2 letters here, they need to go to the bottom. The 9 stays on the top. So this will be 9z to the 8th over x to the 8th, y to the 4th, and we're done. Okay, so moving on to G here. So if you watched my lesson video, so one thing I kind of advocate for is trying to simplify the parentheses first. So I know that we could just go ahead and apply the 5 here, but there is some simplification we can do, so let's just do that first. So that just means we're going to bring the y to the negative fourth down. So this is going to be 5x squared over y to the fourth z squared, and then all of that to the fifth. And now I can go ahead and apply this 5 to everything. So this is going to be 5 to the 5th. Let's see, I'll go ahead and just multiply these all by 5. So this is x to the 10th. This is y to the 20th. And then this is z to the 10th. And what is 5 to the 5th? Ooh, it's a pretty big number, actually. It's 3,125 x to the 10th. Over y to the 20th, and then z to the 10th. So that would be the final answer in that case. Okay, and now the best for last. Maybe, maybe not. Okay, so this one, so it's like we could simplify the inside of the parentheses. Like some of this is just practice and experience. I would say if you just have a line of variables like this, and then you can just go ahead and apply this exponent here, just go ahead and do it. So let's go ahead and just do the multiplication. So what I mean is I'm going to multiply all of these exponents by -3 as shown. So this becomes x to the positive 9th, y to the -6, and then z to the 12th. And now I can see that I've done that. This is the only thing that's got to move to the denominator, right? So this is going to be x to the 9th, z to the 12th over y to the 6th. And so that'll do it for the basic examples. If you guys want to see more, you can always just let me know. You can leave me a comment. Otherwise, thanks for watching, guys. I'll see you next time.